Welcome back. Today we are covering 9.1 section B for our online lecture notes for week 1 of online learning. So let's go ahead and get started. Today we are focusing on trapezoids and kites. Just a reminder that all assignments are due by Sunday at 11:59 p.m. Again, that's three things that are due by that time. You got your 2 homework assessments that are both found in the Schoology folder for practice. And then you also have your 1 assessment that's found in the assessment folder that is also due by 11:59 p.m. on Sunday. New assignments are posted every Monday at 9 a.m. for you guys, so make sure that you guys go ahead and check those out. There will be videos up for you guys, notes that you can actually write on, print out if you need to, and then also note keys. These will hopefully be a little bit more accurate, these videos for you guys. If you do need additional help, make sure that you stop on by for office hours held every weekday, Monday through Friday, 11 a.m. to 1 p.m. I'm going to be in there for 2 hours. If I'm not actively on the screen, if you show up and I'm just not there, just yell my name. I'll come over. I'm probably going to be doing something around the house while you guys are logging in and while I'm waiting for you. So just make sure that you guys get my attention, and I'll come over and help you out. So, a couple things. If you guys do have questions, again, show up for office hours, send me an email about a problem and a picture of your work. That way I can pull it up and actually do it on the screen for you guys in our office hours, and you can actually see the problem being finished up rather than me just do it on a sheet of paper and then try and show you guys the camera of the work and all that stuff. I'd much rather you guys just send it to me, and that way I can pull it up and actually do it with you guys in the office hours if possible. Now, there are going to be a few hit and miss things going on with that. I am learning the technology right now. I haven't really used video conferencing that often, but I am working on learning how to do all this stuff to make it a lot easier for you guys and to help you guys out as much as I can. And of course, I won't be able to help you on anything with the assessments. That's all on you guys, but I will be able to answer any questions prior to that. So, one last thing that is important. If you guys don't have a TI-84 calculator and you need one, right now, Texas Instruments is doing a trial for all students and teachers that will give you the online calculator that they have access to. I am going to go ahead and put this link in Schoology. This is the link that you guys can follow in order to get that software for a free TI-84 while this trial runs on. So make sure that you guys access that. That will make it a little bit easier. And then again, if you're not sure where the office hours are held, they are in Google Meets. So download that app if you need to. You can get it on a computer. You can get it on your phone. Whatever you need to do. Just make sure that you guys have that available to you if you want to contact me. That's going to be the best way that you guys can do that. If no one shows up, that's fine. But I will be in there waiting to help you guys out if you need it. All right, so again, today we're talking about areas of trapezoids, rhombi, and kites. A trapezoid, if we recall, has one set of parallel sides. So these bases here, this is what we call base 1 and base 2, these red lines. Those are our parallel sides. So again, these are parallel to each other, meaning that they'll never touch. And since there's only one pair, that makes a trapezoid. The area of a trapezoid is equal to 1/2 the height. Again, our height is in altitude. It intersects at 90 degrees. In fact, this dashed line over here, that's not a height. It's 1/2 of the height times base 1 plus base 2. So again, base 1 and base 2 are the parallel sides. Our height is an altitude that connects our two bases. So in this case, h is the distance between the parallel sides, and b1 and b2 is the length of the two bases. Now, where this formula comes from, if I have this dashed line here, then what we have is a parallelogram and a triangle. So the formula comes from splitting the trapezoid into that parallelogram, base times height, and the area of a triangle, 1/2 base times height. Adding those areas together will give us the area of a trapezoid, and also this equation right over here. Area is equal to 1/2 height times base 1 plus base 2. Very important that you guys know this one. Very useful for you guys at moving forward with this stuff. So, let's go ahead and try some of these out. Now, with this, there is one other formula for the area of a trapezoid. Very important that we recall that a median of a trapezoid is a line that connects one midpoint to the other midpoint. So we have a line that's created. That's called our median line of a trapezoid. Now, to find the length of a median, we can use the equation 1/2 base 1 plus base 2. So 1/2 times base 1 plus base 2, that is how we can find the length of the median. Now, if this looks kind of familiar, we just saw in the last slide, 1/2 base 1 plus base 2. Strange, it shows up once again, which means that capital M, this is what median, that's our variable for median, capital M is equal to 1/2 times base 1 plus base 2. If all I need to do is multiply this median by the height, and we'll suddenly have another area for a trapezoid. So again, these are the same exact formulas. So let's go ahead and find the length of the median. Well, base 1, I can say is 20. Base 2 is 32. 20 plus 32 gives us 52. 52 times 1/2 will give us 26 units. So again, here's our median line, and it's a median because it's the midpoint on each side, so that's why these are congruent. These are the same length. Same on the other side, same length. And then 1/2 of base 1 plus base 2 gives us 26 units. Now, if I take that median and multiply it by the height, all of a sudden we have the area of a trapezoid. That's the same exact formula as the previous page. So 26 times 10 will give us 260 units squared. So that's the area of this trapezoid, 260 units squared. Fantastic. Let's go ahead and keep moving on. This next example, find the area of the trapezoid. Go ahead and take a second, try this one on your own. If you guys need to pause the video, please pause. That way I'm not just wasting up screen time and making you wait if you're ready. So, looking at this, the area of a trapezoid, area is equal to 1/2 height times base 1 plus base 2. In this case, our height, well, we see that this is intersecting at 90 degrees. This would be our height right here. So height is equal to 3. So 1/2 times 3 times base 1 plus base 2. Well, for base 1 is just the top here. So I have 2 and 7. If I add 2 and 7 together, we get 9. Plus base 2, well, if I look for base 2 down here, I see that we have 9 for this length, for this entire length right here. But I don't have this missing length. Well, I know that this is a parallelogram, and if we think way back, properties of parallelograms say that if I have two sides that are parallel and congruent, the shape is a parallelogram. And we know in parallelograms, opposite sides are congruent. So this would be side length 2. Sorry about that. This would be side length 2 right here. Well, 9 plus 2 will give me 11. So area is equal to 1/2 times 3 times 20. Let's go ahead and see the next page. Right over here, 3 times 20 will give me 60. Half of 60 is 30. So area is equal to 30 units squared. I'm using units because we don't actually have units given to us. So that's what the U is standing for, units squared. All right, let's go ahead and try the next one out. Find the area of the trapezoid. This one's a bit more difficult. So looking at this, is this a height? No, it's not a height because it's not intersecting at 90 degrees. So let's go ahead and draw an altitude here for us. I can draw it on both sides. This is our height. Now if we notice, this is an isosceles trapezoid. So both of these have side lengths 10. If they both have 90-degree angles, and they'll both have 30-degree angles down here. So these are congruent triangles right here because we have isosceles trapezoids. And then again, we have an angle, and then, angle, angle, side, side, angle, angle doesn't necessarily work, but we can use triangle congruency theorems to prove that these triangles are congruent to each other. Within isosceles trapezoids, we know that they can be. Now, if I cut out the same amount on both sides here, because again, these are congruent triangles, then this bottom length will be 8, just from here to here. That's 8. Now, the nice thing about this is that it creates a 30, 60, 90 triangle in both of these. So I know opposite of 30 is x. Let me go ahead and draw my 30, 60, 90 triangle. Opposite of 30 is x. Opposite of 60 is x radical 3. Opposite 90 is 2x. Well, I know 2x is equal to 10. So therefore, x is equal to 5. So our height in this case is 5. Meanwhile, our bottom length, let me go ahead and change colors. Our bottom length is 5 radical 3. That's 5 radical 3 on both sides, 5 rad 3. And then our height over here is also 5. So from here, we can go ahead and find the area of this shape. Area is equal to, well, let's go ahead and focus on our rectangle first. We have 8 times 5, and then plus the area of the two triangles. Well, the area, we have two triangles, so the area of a triangle is 1/2. Base, well, in this case, our base is 5 rad 3. 5 rad 3 times our height, which is 5. So area is equal to 40. 8 times 5 gives us 40. Plus, well, 2 times 1/2, that just cancels. So I'm left with 5 rad 3 times 5. I multiply the numbers out front, which gives us 25 rad 3 units. And here's the work for us. Again, 25 rad 3 units, because 5 rad 3 times 5. The area of the rectangle is 40 units squared. Adding those two together, we get 40 plus 25 rad 3 units squared. This is the most precise answer. Now you may be like, can I just multiply this by rad 3 and then add it all together? Absolutely. But rounding it at some point will cause the area to be just a little bit off. So keep that in mind. This is a perfectly acceptable answer. And you can even go further with it, but it'd be rounded a little bit. So just keep that in mind. All right. Here's a difficult one. So be ready for this. In the written notes, this one's off right now, but just know that this is probably one of the more difficult problems that we'll see. So, go ahead and try this one for a minute, draw it up, do your best on it. If you need to, listen to me go through it, pause the video whenever you need to move a little bit further ahead, and if you get stuck, hopefully I'll be able to help you out with this. So it says, if a trapezoid's perimeter is 55 in non-parallel sides, very important that non-parallel sides, 6 and 9, and height 5. Find the area. So I'm going to go ahead and draw my trapezoid out. So here's my two parallel sides. It's not the best trapezoid, but it's one. I know that it has a height of 5, so I can draw that in here. My height is 5. And the non-parallel sides, well, here's one non-parallel side, 6. The other non-parallel side, 9. I can go ahead and draw a height over here as well if I'd like. And we know the perimeter is equal to 55. All right. Now here's where it starts getting difficult. What we have is we have this entire shape, and we need to find this side length right down here, as well as this side length right down here. Again, I can say that this is equal to 5. If that's the case, I'm going to go ahead and call the rest of this x and x. Because again, it creates a rectangle at this point, and I know that opposite sides of a rectangle are congruent. So, let's go ahead and find these missing pieces. First, to find this green missing piece, I can use Pythagorean's theorem. I'll go ahead and call this y for now. So I have 5 squared plus y squared equals 9 squared. That'll give me 25 plus y squared equals 81. Y squared is equal to 81 minus 25. Well, that'll give us 56. 81 minus 25. Let me double check that. Yep, that'll give me 56. And I take the square root of both sides and we get y is equal to radical 56. Now we are going to be rounding in this one, so keep that in mind. Oops, sorry about that. I'll just go on to the next one. Radical 56. From here, now that I know that this side is radical 56, I can go ahead and do the same for this side length right over here, this small piece. So, once again, using Pythagorean's theorem, 5 squared plus, let's call this z squared. Go ahead and do this. 5 squared plus z squared equals 6 squared. That'll give me 25 plus z squared equals 36. Z squared equals 11. Whoops. So z is equal to radical 11. So that's where this radical 11 comes from. Now, again, we know that this side is x and this side is the same. So from here, if I know that my perimeter is 55, I can say base 1, which is this top one right here, this x, base 1 is equal to 55, that whole perimeter, minus 15, one of the side lengths that we already have. Again, that's from 6 and 9 added together. That'll give me 15, so I minus the 15, minus the radical 56, this portion, minus radical 11, this portion. So again, now I have b1 and b1, so b1 squared, because I'm just multiplying them, b1 squared is equal to about 29.2. Now if I take the square root of both sides, I'm left with b1, base 1, this top portion, is equal to 5.4. That means that b2 is 5.4 plus radical 56 plus radical 11, which will give me about 16.2 units. From here, I can go ahead and use the area formula. Area is equal to 1/2 our height, which is 5, times base 1, which is 5.4, times base 2, which again is 16.2 now, which will give me area is equal to 1/2 5 times 21.6. Now again, this isn't exact, so we're rounding here. If I multiply all this out, we're left with areas equal to about 108.2 units squared. So again, I think that this is the most difficult problem that we have on this whole assignment. In all these notes, I think that this is by far the most difficult. All right, let's keep moving forward. Next, going back to ratios. So, the consecutive sides of an isosceles trapezoid are in the ratio of 5 to 4 to 5 to 10, with a perimeter of 48. Find the area. Go ahead, pause the video, draw this up, try this problem out. All right, getting started on it. I'm going to start by drawing out my trapezoid. So here's my trapezoid. It's isosceles, so I know that opposite sides are congruent, which tells me that it's 5x and 5x. Again, we're dealing with the ratio, so I'm adding in the x's for all these, just like we did earlier this year. The top will be 4x, because that's the smaller side in mine. The bottom will be 10x. We know that the perimeter is equal to 48. So I can say 48 is equal to 5x plus 4x plus 5x plus 10x. This will give me, let's see, 24 is equal to 48. Sorry, 24x is equal to 48. Therefore, x is equal to 2. Well, if x is equal to 2, this bottom length is 20. This top length is 8. This side length is 10, as is the other side length, 10. I'm actually going to switch those 10s because it makes it look like it's the height when it's not. This is 10, and this is 10. All right. From here, we need to find the area. So I'm going to go ahead and break these into triangles. So I know that my height and my base will be perpendicular to each other. So to find this height, we're going to go ahead and create this rectangle right over here that we see. All right, so if we create this rectangle, I notice that this middle length is 8. So if I go back over here, I create my other triangle on the other side as well. I notice that if this is 8 up top, this also must be 8 down below. Well, if these are both 8, and the whole thing is 20 down here, and I know that this is an isosceles, so these should be congruent triangles. The whole thing is 20 and this is 8. That means I have 12 to go through these two equal portions. So if I have 12 to spare between two equal portions, that means that each is 6 in length. If that's the case, then I can find height using Pythagorean's theorem. So I can use h squared plus 6 squared equals 10 squared. H squared plus 36 equals 100. H squared is equal to 64, so therefore h is equal to 8. So our height in this case is 8. Lastly, we can finally finish this one off by plugging it into our area formula for a trapezoid. We're left with area is equal to 1/2 height, which is 8, times base 1, which is 8, plus base 2, which is 20. So it'll give us area is equal to 1/2 times 8 gives us 4, times 28, which is equal to 112 units squared. So that is one of the more difficult ones as well, but definitely possible to do. I think the hardest part is realizing that if this is 8, then this must also be 8, and we need to cut that into equal portions. All right. Getting closer to the end, moving on to the area of a kite. So area of a kite is very nice. The area of a kite is based around the fact that a kite's diagonals are perpendicular. So if we recall the diagonals, the lines going through our object, they're perpendicular to each other, making 90-degree angles all the way around. And if I were to take this bottom triangle here, and I were to rotate it and move it up here, we notice that it creates a nice little rectangle for us. The same could be said if I move this bottom triangle up to the top over here. That also makes a nice little rectangle for us. Looks more like a square in this case, but sometimes it'll be a rectangle. And what would happen is that we would create this shape down here, where we see that one side length is diagonal 1, and if this is a rectangle, this is very nice for us, which it is. We have diagonal 1, and then this side length over here is diagonal 2, divided by 2, because again, this is the whole thing of diagonal 2. If I move it over, that means that I'm cutting it in half. This diagonal is only half of it now. So therefore, that's where this half comes in with diagonal 2. So the area of a kite is equal to 1/2 diagonal 1 multiplied by diagonal 2. So you can use this formula right here, or if you'd like, this is the same exact thing. Area of a kite is equal to d1 times d2 divided by 2. Now, the cool thing about this is that this works for any shape that has perpendicular diagonals. So a rhombus and a square are kites, so the area formula will work for these shapes as well. The reason that they're kites is they all have perpendicular diagonals. So that perpendicular diagonals thing, that will work, and that's why this equation will work for those as well, because we can do the same exact process for those to rotate this around and create that nice shape for us. So keep that in mind. All right, with our new formula, let's go ahead and try some of these out. Find the area of the kite. So if I look at this 12 up here, sorry about that, this 12 up here, that is the entire length of this diagonal. Now with kites, we know that consecutive sides are congruent. We have 90-degree angles. And so if this side length is 4, this side length must also be 4. So very useful for us to remember that. Now, that doesn't mean that this side length and this side length of this diagonal are congruent, but these two will be. So from here, we can use our area formula. Area is equal to 1/2 d1, which is 12, times d2, which is, you're going to think 4, but it's actually both of those combined, which is 8. From here, we're left with area is equal to 48 units squared. All right. Next up, go ahead and draw this one out if you can. Try it out. I'll go ahead and start drawing it myself as well. Pause the video if you need to. Whoops. So, find the area of a rhombus whose perimeter is 20 centimeters and whose longer diagonal is 8. I start by drawing out my rhombus. Now, a rhombus has all congruent sides. All sides are congruent in this rhombus. Diagonals are perpendicular to each other. The longer diagonal is 8. The perimeter is 20. If I know that all sides are equal to each other, that's just 4x is equal to 20. So therefore, each side length is 5. 5 all the way around. Now, that also means that this must be 4, and this must be 4. So from here, I can use Pythagorean's theorem to solve for our missing sides. Oh, well, this is a nice right triangle. This is a special right triangle that we should recall. This is a 3, 4, 5 triangle. So automatically we know that these are 3. Now, if you're like, I still want to use Pythagorean's theorem, please feel free to. That'll give us 25 is equal to 25 is equal to x plus 16. That'll give me 9 is equal to x squared. X is equal to 3. So again, it works once again. I have it right over here for you guys if you need it. At this point, we can use our area formula, 1/2 diagonal 1 times diagonal 2. Well, diagonal 1 is that 8, the longer diagonal. Diagonal 2, well, if this is 3 and this is 3, that diagonal is just 6. So 1/2 of 8 times 6 will give us area is equal to 24 units squared. All right, next up, cute is a kite. Angle UTE is a right angle. UTE, this angle right here is a right angle. UE is equal to 14. And CE is equal to 25. Now, I know consecutive sides in a kite are congruent, so those would both be 25 as well. Now, if we notice this down here, we have 45 degrees. 90 degrees, So this would create a 45, 45, 90 triangle. A 45, 45, 90 triangle. All right, now I also know that this side length would be 7 because the whole thing is 14. So this would also be 7 down here. So what I need to find is the length of CT. So to find the length of CT, well, first off, if this is a 45, 45, 90 triangle, I know that this is an isosceles triangle. So this side length would also be 7 over here. Because again, isosceles triangles have congruent legs. And then I can use Pythagorean's theorem to find our missing side length of C to that center point where the laser pointer is at right now. Let's go ahead and do that. We have 25 squared is equal to 7 squared plus x squared. Doing the math, we get 49 plus x squared is equal to 625. Again, here's what we're looking for. Solving for x, we get x squared equals 576. Take the square root of both sides. Our square root cancels out with the square. We're left with x is equal to 24. So this whole diagonal is 24 plus 7, which is equal to 31. So I have area is equal to 1/2 of diagonal 1, which is 31, times diagonal 2, which is 14. Doing the math, we'll get area is equal to, well, half of 14 is 7. 7 times 31 will give us 217 units squared. So again, just another quick method of going through these. Pythagorean's theorem will be your friend here. Don't forget about Pythagorean's theorem, a squared plus b squared equals c squared, as long as we have right angles. That will be a very big help for you guys as you go through these. All right, this one's a bit more difficult. Find the area. The hint is use altitude on hypotenuse. So I'm going to do something different. I'm going to go ahead and use something that we recall back from the very end of last semester, the very start of this semester. You guys may love it or hate it. Geometric mean. So I'm going to go ahead and use the geometric mean to find the length of this side length right over here. I'll call it x. So if we recall geometric mean, the altitude is what is repeated in our geometric mean. So I have 4 over x is equal to x over 5. Now, very important that we remember that the variable that's repeating, the altitude is always written opposite of each other. So from here, I can go ahead and solve for x using cross multiplication. We get x squared is equal to 20. If I take the square root of both sides, we get x is equal to, well, if I break down 20, I get 4 times 5. So that gives me 2 radical 5. Which means that the whole thing, if both of these are 2 radical 5, then the whole thing would be 4 radical 5. So this leads us to our area formula. Area is equal to 1/2 of 4 radical 5, diagonal 1, times diagonal 2, which is 4 plus 5, or 9. Well, half of 4 gives me 2, so 2 rad 5 times 9 will give me 18 radical 5 units squared. So that's the area of this kite here. All right. I believe this is the last one. Let's go ahead and try this one out. It says find the area of the rhombus. Now, you may be thinking, oh, I got to find diagonals and do a lot of work with all this. Typically true. You can say, oh, this is 15, so on and so forth. I find all this information. I can find the diagonals, all that stuff. All well and good. A much simpler way. If we recall, is a rhombus a parallelogram? Well, yes. So we can use the formula, area is equal to base times height. In this case, our base is 15, because again, all side lengths will be 15 in a rhombus. All side lengths are congruent. And our height is an altitude. Our height is 9. So 9 times 15 will give us 135 units squared. And that's our final answer. Now, there is different ways to go through this, much more complicated ways that take a bit of time, where I can break it down into another triangle, and then I can find the missing side length here and find the area of these two triangles and add it to the area of this rectangle. And that's all well and good. We can do that. It takes a lot longer. If we recall that a rhombus is still a parallelogram, though, base times height still works. So that will still work perfectly fine for you guys. All right. So this is the last set of notes for this week. The assignment that will be due at 11:59 p.m. this Sunday that matches these notes is Day 2, Practice 9.1, Area of Kites and Trapezoids. Again, office hours are held Monday through Friday from 11 a.m. to 1 p.m. for you guys on Google Meets. The information for that is up on Schoology. If you guys have any questions for me, please let me know. Take care of yourselves. I look forward to seeing you guys soon. If you need anything, just please feel free to reach out. Have a great day, guys. Thank you for listening in, and I hope to hear from you guys very soon.